Please give a warm welcome to Carlos Herrero, Trung, and David Brochart to tell us about real-time collaboration in Jupyter.
Hello, everybody. I hope you are having a great JupyterCon. So welcome to our talk about real-time collaboration in Jupyter. That will be done by Trung, Carlos, and myself, David. The three of us work currently at QuantStack. And let's start with the first part, and Carlos.
Thanks, David. So what is collaborative editing? Probably the best way of explaining it is by talking about Google Docs. I'm pretty sure at this point every one of you have used Google Docs or even Google Slides to prepare the presentation, as we did. Basically, collaborative editing is when multiple people can collaborate in the same document at the same time without conflict. But apart of sharing the text, it will be weird if you are collaborating with your colleagues and suddenly some text appear, you don't know who is writing or where. So it's also important to have some collaborative features like having a list of collaborators, also sharing the cursor or sharing the selections. Now, if we move a little bit into the notebook format is not a very easy format for real-time collaboration. We could look at the format as multi-layer document, let's say. Basically, in the first layer, we have multiple cells that users can create some actions like inserting a cell, deleting a cell, moving it, while at the same time, other users can be writing in one of the cells, collapsing it, or changing the type of the cell from Markdown to a code cell, for example. That generates a lot of conflicts that has to be resolved automatically. So during the history of the notebook, there has been multiple attempts in trying to make the notebook collaborative. The first one from Google. In Google Colab, they made it collaborative using the Google real-time engine, but it was deprecated later in 2017. And right now, Google Colab is not collaborative. There was another attempt from William Stein, which is actually collaborative. It's quite impressive. You should check out CoCalc. It's awesome what he did all by himself. He rewrote the notebook entirely, thinking on collaboration first. And regarding JupyterLab, from the beginning, we wanted to have collaboration. And the team from Brian, Chris Colbert, and Ian made JupyterLab collaborative using the Google real-time engine, but it was later deprecated. There was also, once it was deprecated, Chris Colbert implemented the Luminous CRDT, and they also tried to integrate it into JupyterLab later on. Finally, in 2021, we got real-time collaboration in JupyterLab using the YJS framework. This implementation was done by Kevin Jans, the author of YJS, and also Eric Charles. And so for those interested in the technical part, I don't want to enter in too much detail. I just want to say that we are using conflict-free replicated data types, CRDTs. Basically, CRDTs are data types with automatic conflict resolution. They don't really need a central authority for resolving the conflicts, which gives us a strong eventual consistency, which means at some point, eventually, everyone will end up with the same content. Our current implementation, as I said before, is based on the YCRDT implemented from Kevin. And YJS is an open source framework for building collaborative applications. It's well optimized, and we can say it's network agnostic. It doesn't matter what protocol you use for sharing the updates between the different clients. It has some other key features like awareness, configurable undo manager, offline editing, snapshots, and commenting that are also key features for Jupyter. Well, the current implementation in JupyterLab 4, we decided to move real-time collaboration outside of core JupyterLab. We move it into an extension that you can install and try it out. It's called Jupyter Collaboration. And basically, the architecture is based on a central authority. We have a backend where every update from every peer is broadcasted through this server. And at the same time, it's in charge of loading the documents from disk. But that's not the only architecture we can implement. For example, for JupyterLab, we could implement, actually we have already an extension for JupyterLab that uses WebRTC to share the updates between the peers using peer-to-peer. And now I'm going to let David continue with the presentation.
Thanks, Carlos, for the overview. Now let's dive into a bit more details about the API with some Python code. So the way it works is quite simple. You first need to create an instance of a Y document, and then you start giving structure to this document. In this case, we are getting a text type from it. And then we can make changes to this structure. So right now we are inserting the hello world string in it. And you can see that every change to the shared document has to be done through a transaction. So that's why we have this context manager. And this ensures that every change to the document is atomic. So a change to a document creates an update, which is a very efficiency encoded data in binary. And you can observe changes to a shared document. For example, JupyterLab frontend does that to react on every change and update the UI accordingly. But also the other way around. So if you change something in the UI in JupyterLab and that affects a shared document, this is sent over the wire to the server, which then broadcasts everything to every other connected peers. So the current architecture we have in Jupyter is a centralized one because everything goes through the Jupyter server. Actually, it's a slightly different package, which is called Jupyter Collaboration. You just need to pip install Jupyter Collaboration, and JupyterLab magically becomes collaborative. So the way it works is that you first need to request an ID for a file, because we don't want to work with file paths as is, because these files can be renamed or deleted or whatever, and we need to track these changes too. So that's the responsibility of the Jupyter Server File ID package. So you request an ID for a file path, and then you only deal with this ID in the future. The next step is opening a WebSocket to the server with this file ID. And every shared document updates are received by the server from each client and broadcast to every other client, but also saved to file. So we have a notion of room. The room is the space where all clients collaborate on a common shared document. A room holds a view of that document. A view can be, for example, a notebook view, the notebook we are used to, with a rich representation in JupyterLab, with cells that we can execute, the content of cells that we can change, and so on. Or we can also open the notebook as a JSON view, and then it's a completely different structure. It's not the same Y document. We won't be able to execute cells, for example, or even as a plain text file. The Y updates, the changes that are made to the document are persisted to what we call a Y store, which is usually an SQLite database, but it can also be a regular file or even sent on the cloud. This allows us to replay changes to a document. For instance, for debugging, we used to use that a lot in the early days when we were developing. But in the future, we also want to have a graphical timeline in JupyterLab that will allow us to go back to any point in past, to go back to a previous version of a document. So Jupyter YDoc is another major package which is responsible for defining the structure of shared documents. It ships with a number of documents that we use a lot in JupyterLab. So of course, the notebook, a plain text document, but even also a binary blob. These shared documents are extensible through an entry point, so you can register your own custom document if you want. You just need to ensure that this document complies with the API, so it must, for example, implement methods to convert between the source and the shared document in both directions, and also methods to observe changes to parts of the document and to be able to react to it. For instance, when we create a new cell in a notebook, that will trigger a special event, or when we edit a text inside a cell, that's another trigger. There is also some experimental work with collaboration in Jupyter because of the experience we are getting with notebooks. We are trying to generalize this approach and apply it, for example, for Jupyter widgets to make them collaborative. So this is well suited for use cases where widgets are tied to a stored document. For instance, a CAD model. Trung is going to talk about that in just a minute. So the way it works is that, the use case is like the following. For instance, you have a widget which handles a shared document through JupyterLab extension, for example. In this case, it's without a kernel. And you make manual changes to this widget, and this reflects in the shared document. But you may also want to attach a kernel to it to do programmatic changes. So in this case, JupyterLab works the way I described just earlier. So it opens a room for the shared document. This has the advantages of being well authenticated and having a single point for saving to file. And the kernel doesn't access the shared document directly, but through JupyterLab, through a Y over kernel COM protocol for those who know a bit the details of the kernel protocol. So this works pretty well, but it has the drawback of needing an extra hop in the network, because basically the kernel, which lives in the backend, first communicates with JupyterLab in the front end, which then communicates back again with the backend. We could go directly from backend to backend, and this is actually something we are thinking about implementing in the future. And Trung will now present a use case with JupyterCAD.
Thanks, David. And I want to continue the presentation to talk about an application of RTC outside of notebook. And David and Carlos did a great talk about how we build RTC in JupyterLab. And all these S4 are not only to support notebook, and it is built as a component of JupyterLab with extension in mind. So for me as a extension developer, when I look at JupyterLab, I can see it as a scientific application shell. Because JupyterLab proposes layout component. For example, we have menu bar, expandable panel, we have movable, resizable tab panel, command palette, and so on, which is very useful to build complex interface. And it supports also theme, accessibility, localization. And when I finish my app, I can deploy it at scale with Jupyter Hub. And now on the work with real-time collaboration, JupyterLab provides also a framework to build real-time collaboration application. So to illustrate the idea of using JupyterLab to build complex application, we created JupyterCAD. Here is a screenshot of interface of JupyterCAD, and it's a 3D geometry modeling software built by using JupyterLab component. And for the geometry creation, we use Open CAD kernel. It's a very well-known and open source CAD kernel. And JupyterCAD have its own file format, but it supports also FreeCAD native format, which is also free and open source 3D geometry modeling software. And of course, JupyterCAD support also real-time collaboration. And here I will show a demo of the geometry feature of JupyterCAD. We have a 2D sketcher where I can draw a 2D geometry and save it, and then I can use the operator. For example, here I use an extrusion to create a 3D object from my 2D sketcher, and I can make it a solid object. And we support also the primitive 3D shape. For example, I can create a box from its 3 dimensions, and I can add a cylinder to my scene. And then I can use because we have an open cascade, add a CAD kernel, we can have a Boolean operator, and we can use a cut operator to create a hole on my box. And all these geometry operators are all the geometry operators are done on the browser because we use a WebAssembly version of Open Cascade, so the server does not to handle all the geometry computation, and the server requirement for JupyterCAD is very low. And with the flexibility of JupyterLab, we can build JupyterCAD 1 and deploy it in different forms. We have a first form, a standalone, we call it a standalone app, which is a steamed down version of JupyterLab, where we remove all notebook-related features to have a very simple interface focused on geometry. And this standalone app targets the engineer who don't have knowledge on programming. They just want to focus on geometry. JupyterCAD can also be deployed as a JupyterLab extension. Here I have a interface, the normal interface of JupyterLab, where I can open notebook and writing code. And I have also the interface of JupyterCAD, where I can work with my geometry. And this kind of extension targets the intermediate user who want both have the JupyterCAD interface and also the notebook to do data analysis. And JupyterCAD can also be a notebook widget. We can use it inside a notebook, and it targets advanced users who want to use the JupyterCAD API to modify the geometry programmatically. And actually, to build this widget inside notebook, we use the Wi-Fi widget of David. He talked before. And we have different kind of audience, but they can all work together by using the RTC of JupyterLab. Here I have a demo of 3 users using 3 kind of clients. They work together on the same file. So I have a notebook user adding a box to my file by using the Python API. And 2 other users on the standalone app and on the JupyterLab extension. They can also add different objects to the scene. They can remove objects and modify the property of the object. And at the end, all 3 users got the same output because we reused the resolution, the config resolution of JupyterLab. And we have not only the the collaboration on file editing, we have also other social aspect. For example, we have also a comment system where you can add annotation to a species object, a position of an object. Here, one user can add a comment on an object, and it will be shown immediately on other client. And we have also follow mode. For example, here I have a user on the right, if following user on the left, and for the user on the right, the screen have a border highlighted with the color of the user they are following. And when they are in follow mode, when user on the left, they change the camera, they change the position of the object, it will be updated on other client which are following him. And not only about the camera and the position, when the user on the left open a dialog and they working on a field, this dialog is also open on other user, and this field is also highlighted to inform the current user on the right that what the user on the left are doing. And by using this follow mode, one user in JupyterCAD can show other user how to use JupyterCAD in real time. So JupyterCAD is still in development phase, but it already available on PyPy. You can try it with pip install JupyterCAD, and the project is hosted on GitHub, and your contribution and feedback are really welcome. And on this feature about RTC already will be available in the next release of JupyterLab, JupyterLab 4.0, which I think will be released in a few days. And this is some element we will work on in the near future. The first is a commenting and chat system, similar in JupyterCAD, but we will add it to JupyterLab to allow users to comment on a notebook. And we also will add the timeline, like David already said, a graph of history, so we can come back to any point in the past of the notebook. And we will want to have also the real identity to identify the user and to have more control on reading and writing right on a notebook. Thank you very much for your attention.
Hey, thank you. Any questions? Okay.
Thank you for the presentation. Is there any tutorial how to do the extension that support RTC? And the second question, is there any limit for number of users that can use, that can be using notebook in the same time with RTC? Is there any limit?
So there is currently, I think, no tutorial for making shared documents, but there are, of course, shared examples. But you would need to have register your custom document in Jupyter YDoc, and probably also have a JupyterLab extension that handles it. And as far as the number of people who can collaborate, we currently didn't notice any limit. But for sure, because it's a centralized architecture, there will be, for sure. We can still work on that and, for example, compile more code, low-level code to native code if it's required. That would be one of the ways to improve it.
I have a question. If a couple of people are working real-time together on a notebook, and an additional person begins to work on it, do those who are working on it get any kind of a notification that there is now one more person?
So there is the awareness system. So for example, in a notebook, you will see the name of someone who is typing in a cell, for example. Right now, it's everybody has a name like Anonymous followed by a random name, but As we said, one of the directions we are going to work on is providing kind of real identity, so you will be able to recognize people that way.
Any other questions?
Yeah, I just, is it kind of ready to work? So I've got like a Jupyter hub. Could I just, if I just installed Jupyter Collaboration, then the JupyterLab instance on that Jupyter hub would now be collaborative?
I'm not sure I understood the question. Is it related to Jupyter Hub?
Yes,
Okay.
yeah.
Yeah.
Does it work on Jupyter Hub, I guess, is the question.
So this is, there is a lot of work in progress for that. Jupyter Hub is also getting support for permissions, roles for users, role-based access system, and so on. Min, who is a major contributor, is working on that. He's over there. He can probably answer that question better than me if you want to come down, or maybe they can ask, you can ask him later. Sorry? Okay, it's already supported.
Okay, any more questions? Okay, thank you very much.